Okay, looking at this region, again, the same region I sketched here, we got the parabolic section, we got the cylindrical section, and we got the truncating plane, right? Just looking at that shape, seems to me that we'd start by saying x goes from -1 to 1. Why? Because then all we have to do is our typical x always goes from the parabola to the plane. So if our x star is here, okay, we see that y goes from and for every x, we've got a cross section that goes all the way from here to here. Okay? That makes sense? So how are we going to write that?
So y is going from x squared to 2 minus x.
Actually, it's going to be
X squared minus 2.
Yeah.
2x minus
x squared would start here.
Yeah.
Okay, it's x squared minus 2. And then, as you say, it's going to be 2 minus x, because x plus y equals 2 here, right? So let's just note that this is x plus y equals 2 here. And x squared minus 2 equals y here, because now this is in the plane z equals 0, right? Since it's the plane z equals 0, then our y equals, well, this becomes this. I have to explain that. Okay? Okay, well, then what can you say about z? Well, you got to go from the lower half of the cylinder to the upper half of the cylinder, right? At every point. And the cylinder is only in x and z, right? And then from the lower half of the cylinder to the upper half. Okay? And how do you do that? Well, x squared plus z squared is 1. So on the cylinder, z is plus or minus the square root of 1 minus x squared. So it goes from the minus to the plus. So that's going to be a fairly straightforward integral, isn't it? Okay? Now we have to do, we want to integrate this over the surface. Now what we're integrating is we want to integrate the normal component of this over the surface, right? So we can say now that our integral over the surface, closed surface, of f dot n with respect to area is equal to our triple integral over the region of del dot f dv, right? And what's del dot F?
Let's see.
Sorry? I heard a short answer, and it is a short answer.
IJK. IJK. I plus J plus K.
Well, then when you do the dot product, you don't end up with I's, J's, and K's.
Oh, just
Do
three.
a cross product, you do.
3.
Yeah, 3. So I meant short answer, okay? And that equals then the integral of 3 dz dy dx, z going from negative square root of 1 minus x squared to the square root of 1 minus x squared, y going from x squared minus 2 to 2 minus x, and x going from negative 1 to 1. Okay? That's an easy integral. And think about how that would compare with the integral, trying to integrate the normal component of this over the surface. Okay? You could parameterize this section of the surface, you could parameterize the section from here to here, and then you could parameterize the section from here to here, and you probably use different types of parameterization, at least especially from here to here, right? Because you're bounded by a plane. Everything else is circular cross sections, so you know, you have a natural way to parameterize those, right? These are partial circles, and maybe you do it that way, and maybe you do it another way, okay? But you parameterize these 3 sections, and then you got to do the component of this normal to this surface, okay? Now on a sphere, the component of this normal to the surface, well, this is always normal to the surface, right? But on a cylinder, because this is radial, you know, it emanates out like spokes from the origin. On a cylinder, it keeps hitting at different angles, right? And then it has to hit this thing, but at a constant angle, so that part might not be too bad, okay? But it doesn't hit anything else at a constant angle, so you're going to have a fairly complicated expression when you try to do the F dot N on that surface, okay? That's going to be, at best, a mess, and at worst, something you can't even integrate by standard techniques. And you're not going to have a lot of symmetry, at least at this end. You do have symmetries within here that might help, okay? But, you know, pretty much out of luck if you try to do this, or at least you've got bad luck if you don't see that you can do this, which is very easy.